this session.
Thank you for that advice. I'm definitely gonna.
Okay. Yeah, a few of my things I have actually put up. In fact, there's one that's particularly apropos here. Where is that? Let's see. Oh, yes, it's called the phylogeny of, let's see, the phylogeny of play. Let me just. There it is. And here is a lecture with slides that I simply turned into a web page. And you can pretty well figure out, basically the text on the web page is what I was saying. And the only thing is that in the, do I have the, no, that in this version, I don't have a couple of videos that I used. So anyway, oops, let's get moving here. Okay, then. So I'm going to talk today about gossip systems for interactive storytelling. And I will begin. First, let me point out, what is this?
Oh, I found your plays.
Okay.
Or I found 1 of 3 and 3 of 3.
Okay, good.
Yeah. Oh, I found 2 of 3. Awesome. On YouTube.
Okay. Let's see. First, I'll point out gossip systems for interactive storytelling basically come in 2 levels. Very simple and very complex. There is a middle ground, but it's very easy to do the simple stuff. And as soon as you want to go beyond that, it gets a lot more complicated. I will also point out at the beginning that gossip systems are only appropriate when we're talking about multi-agent interaction. That is, you cannot use a gossip system in interactive fiction because there's only one agent, the player. And so there's nothing that anybody else can do that would come as a surprise to the player. If there is another character in the interactive fiction, what the character does is presented directly. And so there's no variable activity on the part of other agents, and so there's no need for gossip. In fact, no utility at all for gossip. In any system where there's only one active agent, gossip is useless. In fact, inappropriate. Now let me talk about the simple form of gossip. And that's actually what I did way back in 1983 with my first game called Gossip, and which I also did with the Gossip game I did about 5-10 years ago. Now, there are 3 basic structures you can use, and I'll present them this way. In the first, you simply say that the subject tells the direct object that the subject feels something about indirect object. In other words, Fred can tell Mary, I really hate Bob. This is a very simple form. And really, you almost always need to go beyond it. And in fact, from the very beginning, I went beyond that. The second form extends it a little further, subject tells direct object that indirect object feels Q about direct object. So, in other words, Joe tells Mary that Bob hates, actually in the simplest form, it would be Bob hates Mary, but it could also be that Bob hates John. So you could actually have four people involved here: subject, direct object, first indirect object, and second indirect object. That's the third item on this list. So that's the full range of action. I need to show you. Oh, darn it. I didn't bring that out. Did I? Yes, I did. Okay. There. So in that array, that's just a, oh, by the way, in the simplest forms, you use a single relationship variable, you know, P bad good. So that's the basic form, and it's fairly simple. You can easily see the stuff I did. However, it can be extended in quite a few ways. For example, you could have multiple relationships. In other words, Fred tells John that he doesn't trust Mary, or Fred tells John that he's rather intimidated by Mary. Those are some of the basic extent, so you can extend the relationships. That makes it more complicated in practice. I don't think it adds a lot to this type of, by the way, this is really more of a game than an interactive story world, because you're not really getting many events other than the descriptions. Let's see, but one of the big problems with gossip is the presentation of the, is when the player wishes to express something of his own. That is, the player decides, I need to explain, or I want to say that Mary, blah, blah, blah. And the difficulty here is remembering what he has already heard. In other words, here you are halfway through and you've gotten all of these statements from all of these people, and it's very difficult to keep track of who said what about whom. Normally, the way you would do this is have some sort of diary or history book is what I call this, and you can scroll back through it to check everything, and you can have you know, sort of database filtering, so you can say, well, show me everything that Tom said, or even show me everything that Tom said about Mary, and that can whittle it down. However, I came up with a scheme that I think is ideal. Wait a minute, come on here. I want to send a picture there, and there it is. This is the display I used for my more recent gossip game, and I'm very proud of this. Very, very clever. You got 6 characters here, and the way it presents is that the character who is speaking is put in a white halo. The character who is being spoken to is in a blue halo, in this case, Zoe. The character who is being spoken about is in a pink halo, in this case, Ella. Now, the neat thing about this is that cute little histogram that summarizes everything that you know about what other characters feel. And the color of the arrows indicates whether the feeling is positive or negative. Whoops. And grab a mouse here, and the here we go. The let's see what else about it. The thickness of it indicates the confidence that you have in that value. So, well, I may have changed that towards the end. So, for example, we've got a red pair. Mort hates Ella. Ella hates Mort. Oh, I'm sorry. Red is positive, blue is negative. So Mort and Ella like each other, and Max and you like each other. Down at the bottom, you can see that Zoe and Mort kind of sort of like each other a little bit. On the other hand, Zoe and Max really hate each other, but it is not necessary that these relationships be symmetric. You will notice, for example, that Owen kind of likes you, but you feel completely neutral about Owen. Similarly, you rather dislike Zoe, but Zoe feels neutral about you. This is early in the game when you haven't figured out very much, and so everything sort of looks symmetric. But this is a nice, clean, graphical way of presenting all of the information from the whole experience in a single display. It is rather cryptic, I suppose, but it is still a one way of solving this problem. I will tell you, this problem is one of the major factors resulting in my abandonment of the CBOOT project, largely because the CBOOT display system used an iconic language. And unfortunately, the iconic language gobbled up lots of screen real estate, and that in turn meant that that presenting past results, presenting the history book, presented a lot of space, and it took a lot of time scrolling through this long history book. It wasn't very practical at all. It was quite tedious, and I simply could not come up with any better solution. Now, it would be tempting to say, well, this argues in favor of a natural language user interface. I'm going to defer that until I move away from this. I have to defer that until I start discussing language-based story worlds. Anyway, so simple gossip games where people are just talking to each other on the telephone. Those are easily done, and they, in fact, I urge you, if you really want to understand gossip systems, it would be very wise to start off doing a simple teenager gossip game where they're all calling each other and telling each other how somebody feels about somebody else. That's a very simple, straightforward thing to do, and it's a very good way to get started, because I warn you, as soon as you get into anything deeper, it gets a lot deeper very suddenly, and you will find you'll get lost very easily. So do that as a training exercise. Once you move beyond the simple gossip, the talking to each other about who feels what about whom, things get complicated. Now, the first approach is the language-based approach, which is what I built with Storytron. And that is very powerful, but too complex to actually use. Let's see, in that case, basically in this general class of story worlds, you're using a toy language system where you create an artificial language that people can both speak to the computer with and the computer speaks to them with it. At this point, I'm going to digress very slightly, no, a lot, and talk about a very important point here about why we use toy languages. It has to do with an old principle I first gave voice to, God, it was at least 30 years ago, in a lecture that I don't think was recorded, but I was talking about some user interface principles in game design. And I introduced a very important concept, and that is the difference between conceivable states and accessible states. You see, every user interface makes certain states accessible to the player. That is, you can be in text entry state and be typing away your text. That's a state. But you could then go to a font selection state or a tab assignment state in a word processor. So every piece of software gives the user a set of accessible states. The problem is that the user has an imagination and can imagine states that should be accessible. In other words, if we're talking about a word processor, if you make it possible for the user to have a document 3 pages long, the user has every reason to expect that you can make a document 4 pages long. He expects the state of 4 pages to be accessible. Now, in this case, so that's a conceivable state, and it is also accessible. That's good. But there are lots of situations where the user conceives of a state that is not accessible. You know, why can't I have this character that exists only in Finnish? Well, my alphabet set doesn't include that character. That is a conceivable state that is not accessible in some cases. In most computers, it is accessible. But your problem is that you've got this very imaginative user, and those imaginative users are always going to imagine or conceive of things that you didn't make available. In games, the classic version of this is every game has a map, and every map has an edge. And what happens when the user comes to the edge? And there are all sorts of hokey solutions to this. One is to have spherical worlds, so there's no real edge. Another is to just have a great big brick wall, and you come up to it, sorry, can't climb over that. There are all sorts of schemes for dealing with edges. Another solution, which I consider to be rather stupid, is to try to make the map apparently infinite. And you just keep generating more planets or galaxies as the user moves around. And that merely makes a world that is too damn big to be really usable. So anything you do, anything you put into the design generates conceivable states. And one of the major tricks in good design is to ensure that the number of conceivable states is exactly equal to the number of accessible states. Or to put it another way, the ratio of conceivable states to accessible states is 1. In almost all software products, that ratio is greater than 1. People can imagine a lot of things that they'd like to do that they can't do. And that, in fact, is one of the greatest sources of frustration people have with software. You know, why can't I do this? I should be able to. And they're searching around through the menus and dialogues and looking up help and getting online. Why can't I do this? In fact, if you analyze most of the discussion and on user groups and help websites, It's almost always takes the form of, I want to do this. I should be able to do it. How do I do it? And frequently they just come back and say, no, you can't. I will give you a personal example of a major design blunder. This is in the website manager WordPress. Very popular, tons of people use it. A few years back, for years, I've been using a program called Sandvox, which is a website editor. The only thing is the publisher went out of business about 6 years ago. And so there was no longer any support for Sandvox. And it was obvious that at some point Sandvox would become obsolete and would not be usable anymore. And all the Sandbox users, spent a lot of time discussing alternatives. Where do we go after this? Well, I had a particular problem in that my website, erasmataz.com, is huge. It's got over 1,500 pages of material. And so the architecture for it is a gigantic tree with a lot of hyperlinks between pages. It's navigating it is rather difficult. Even more important, linking pages together. Here I am writing an essay, and I want to refer back to something else I wrote on a related topic in a completely different section of the library. Well, with Sandbox, it's fairly easy because there's a hierarchical menu structure that allows me to go through the website and isolate the page I want. And that's obvious. Whenever we're dealing with, lots of items like a file directory, you don't just list all of the files. There are tens of thousands of files. You use a menu hierarchy that makes it easy to zero in on the file you want. So I spent months researching, and I finally decided on WordPress. However, the biggest problem with changing website managers is that each one has its own custom format, which means that somebody had to go through and page by page convert from the old format to the new format. And there were some technical tricks involved with some of them. So I hired somebody to do that. I paid $4,000 for the transition, which hurt, but had to be done. And then I'd had long discussions with this lady about exactly what would be involved, and I thought I understood it. But after she turned it all over to me and I went to work to operate this thing and do my own editing in it, I ran into a problem. If in WordPress, you wish to insert a link to another page in your website, you pull up a menu. The menu lists all of the pages in alphabetical order. It does not use a hierarchical menu, which means that the menu is 1,500 items long. This is absurd. This is ridiculous. It is entirely reasonable for me to conceive of the use of a hierarchical menu, which would make it much easier to access these things. But alas, WordPress designers are so idiotic that never occurred to them. And so I went on to the WordPress user forum and asked, surely this is not their intention. Surely they have some way of dealing with this issue. And basically people came back and said, no, it can't be done. And I then said, come on, who could have made such a big mistake? At which point they got mad at me and said, how dare you criticize our beautiful WordPress? And So I walked away from that, threw away my $4,000 investment, and went back to Sandbox. So anyway, that's a very good example of the screw up on conceivable versus accessible states. Now I can bring this point to bear. This is why we have to use toy languages. If you use a natural language, you are automatically telling the user that all conceivable expressions in that language are accessible, because you're making some of those expressions accessible, but you're not saying which ones. And so you get into a classic problem called Parser Puzzles. And it has always been a killer problem with interactive fiction and a number of other structures. Now, the solution to this is something, actually Texas Instruments came up with the basic concept in the 1970s and patented it, but I discovered it independently, and I think I developed it in a way that makes it more, I mean, the TI patent, it's really hard to figure out what they mean. Whereas I documented my design much more thoroughly, and it's more practical, and it's a concept I call inverse parsers, and I've got lots of discussion of that matter on my website. An inverse parser runs a parser backwards. In a regular parser, what you do is the user types in, I want to be able to do this, and then he humbly submits his input to the grand authority parser, and the parser goes through and evaluates the text stream and determines whether or not it is valid text. And if it is not valid text, it comes back, input rejected, invalid input, you did it wrong, you used bad words, go to hell. And this is rather frustrating for most users. The inverse parser does that all ahead of time. That is, at any given instant, the inverse parser goes through all possible things that the user could say at this point, and then puts them into a menu and says, okay, here's what you can say next. You can use this word, this one, or that one. Pick which one. And this way it is guaranteed that everything the user can say is automatically valid. This does require the user to go through a menu sequence. In building, basically the user's command is a sentence. Everything you do with a computer, you're giving it sentences. In the classic user interface structure that Macintosh introduced commercially, it's the structure is object verb. So you select a document and then you use the verb open, or you select an application and use the verb open or run. That was the classic structure, which lasted for a while, but then they started realizing that there were some sentences that required 3 words, and some that required 4, and so forth. That is, open this with that, whatever. And so the first solution to that was dialog boxes. That is, the dialog box allowed you to fill in all the additional specifications for your or your input. However, the right way to do this is to just enter a sentence, just say what you want to say. And so do this with that using that technique. And if you're going to enter a sentence, easily the best way to do that is with an inverse parser. Now, let me look at Sasha's comment here. When reading from one can search for the title of the article one is linking to, and a WordPress will give the author the link to it. One simply highlights the text language. Yeah, clicks the link icon and types a few characters. Yes, that was something somebody had in fact suggested And in practice, that's actually pretty damn clumsy. I mean, it is the best solution, but I don't know. When you have 1,500 pages, differentiating the page title, especially when you don't remember them all, is not very practical. Whereas coming in through the hierarchy, you can say, yeah, that was the page in the section on hamsters, wasn't it? So anyway, but yeah, that was the best solution somebody offered. Anyway, oh yes, Ajman.
Hi, Chris. I just want to ask quickly, do you currently have a patent for the inverse parser? Would we be able to use that mechanic if we wanted to? Or do you have a patent?
No, because although I do have a general purpose one, the dicto system in Storytron is a general purpose parser system. But the problem is that the parser doesn't exist in isolation from its vocabulary. The parser must understand the meaning of each and every word that it uses so as to be able to determine whether or not a word is appropriate. For example, suppose you want to say something like, I give an object to a person. In selecting words, the parser has to know what words are objects, movable objects, and what words are people. And so it has to be able to look up every word and determine its attributes. And this can get very complicated. And so the dicto system has a way of doing this, of defining attributes of words, and then so that dicto can sort through and figure out what's appropriate. The first time I did an inverse parser was with CBoot, the first CBoot in 1987. And for that I used, I built by hand all the logical constraints. I had this gigantic Boolean expression that basically returned true or false. True means, yes, you can put this word into the menu. False means you can't. It went on for like a full page of Boolean, this and or that, or this and that, and on and on and on and on. So with the dicto system, I abstracted it to something that could be generalized. Yes, there is something in there. You're welcome to look at the dicto system, and whoops, come on, let's see the chat. And if you'd like, if you have questions about it, just email me and I'll be happy to explain some of the details. Yeah, I'm not sure if the source code, I believe, should be available on the Storytron website that, oh, come on, the guy, fellow took it over for me. And he wanted to take it in his own direction. I don't know what he's done with it. Anyway, just go to storytron.com and see what you can find there. There is also a tutorial. There's several tutorials on the technology. I believe at least one of them is on the Storytron website, and that can at least give you an idea of how the dicto system functions. And actually, I believe it is thorough enough that you can figure out the code yourself just from the description of what it does. So at least I think so. Let's see what else. So you need to use a toy language instead of a natural language. And dicto is a very good way of doing that. I hope people will shamelessly steal whatever good ideas there are in dicto. I'm not sure that it can be simplified much. I mean, there are a number of features that were obviously tacked on, and they can obviously be removed. But the core system was pretty fundamental in its structure. So anyway, so you're going to use a toy language. Fortunately, the Dicto system doesn't care whether the toy language is iconic or textual. And in fact, I've used it both ways. When you present a menu, you can have huge chunks, an entire paragraph as a menu option. There's no restriction like that. So that's one way to do it. But no matter what, you're going to have to use the toy language. That is necessary then. And you're going to have to, your story world is going to generate events. An event is basically a sentence. So-and-so did such and such to somebody. That event, that sentence, when it is executed, is recorded in the history book, a fundamental structure for every story world. You got to keep track of what has happened in the past. And in fact, I'll point out there is some overlap between events and relationships. That is, theoretically, you could have a story world that has only the history book as its structure or as its memory of, and you wouldn't have to keep track of relationships at all. If you want to know if somebody likes somebody, well, you just go through the entire history book and see what has happened between them, and then calculate their feelings towards it from previous events. That approach, though, is rather time intensive. And so really emotions are digested experience. Relationships are ways of taking the entire experience with another person and boiling it down to a number. So how many times has this person betrayed my trust? How many times has this person lived up to his promises? You can boil all that down to one number that you call trust, or P honest, or P faithless honest. And that's a very handy way. In fact, I believe that neurophysiologically, emotions are just that, a very handy way for a brain to keep track of important relationships. It has a sort of a hard level and a soft level. A hard level would be big teeth, fear, or big breasts, sex. Those are sort of hardwired. But then there are a lot of soft wired. Basically, your experience with this person has led you to like them, and so you can base your actions based just on this single digested experience. So, and in fact, theoretically, you could do a story world without a history book in which every event is automatically digested to some relationship. But in order to pull that off properly, you really do need to have a pretty broad set of relationships. So these are interesting areas to research. Yeah, go ahead, Ashma.
Yeah, I just want to ask, do you think it's necessary to have just one universal history book? Because in my implementation, every different character has their own history book. So their experience of the world is entirely subjective to that character. They don't have access to like one central database. What do you think?
Oh, well, that's easily enough. I mean, either way works. My method is to have the one universal history book. And then when the event takes place, we record, in addition to the basic event, so-and-so did such and such to somebody, we record when it took place, where it took place, and who witnessed it. We have an array of flags, one for each character, And basically that's very important for the gossip system later on. And so you can just do database filtering. You want to know what one character knows, sweep through the history book and extract all of the things that he knows about. That eats up more cycles, but nowadays it's ridiculous. You just don't worry about memory or execution time. It's just not fair. I had to sweat this stuff so much back in the Atari days. You guys just, who cares? Throw memory at it. So anyway, let's see. So the history book then, as the story world progresses, as the story progresses within the story world, you're recording the history book, and there will be witnesses to events, sometimes very few, sometimes a great many, but you're recording that. Here's where the gossip system can kick in. Each character, there's a general solution that eats up a lot more cycles, but I found it was just a lot simpler to have what I call a headlines array. Each character keeps an array of headlines, events that the character knows about, that the character deems to be important enough to gossip about. Now, this relies on a crucial element of verbs that a lot of people that I realized was crucial very early. And so far, I haven't seen people much talking about it. And that's what I call the intrinsic import of a verb. That is, this is an attribute of the verb. When you define the verb, you define its intrinsic import. And that import varies. For example, if you have a verb called pick up a piece of litter, then the intrinsic import of it is very, very low. If, on the other hand, you have a verb called, set off a nuclear bomb, that has very high intrinsic import. And so for each verb, you're going to assign intrinsic imports. Now, that's only the verb's import. For a witness, the import, there's the local import. In other words, intrinsic verb import, local character import. And that depends on who was the subject of the verb, who was the direct object, and what were the other terms. And so you need an algorithm to calculate local import for a given character for any given event. And that's going to depend on how much the character in question cares about the subject and the direct object and so forth. And so you can have, in other words, if your best friend breaks up with his girlfriend, who's your sister, well, you care about both of those people. This has very high local import. And so you calculate the local imports for each of these, for each headline, and you prioritize, you sort the headline list by local import. So at the top of that list is going to be the most important things that you know about, and going down from there. You can also look up who knows about it. And so you come to, when our character encounters another character, the character can first consult his local his headline list and start at the top and say, should I tell this person about this headline? And at this point, we do something that is bad simulation and good drama. And that is the character looks up whether this guy knows it. In other words, I got this great headline. Hey, Kennedy was assassinated. And then I look up his entry, his flag for that event and find out, oh, he already knows it. Let's skip down to the next one. Again, this is not good simulation, but it is essential to drama, because in drama, if somebody keeps telling you stuff you already know, it's boring. So our character goes down through his headline list looking for a headline that this character doesn't know. And then this character has to decide whether to tell him that. And that's going to, you can do that. You can just say, I'll tell him no matter what, or you can get clever and throw in stuff about how much this character trusts that character and likes that character, should I tell him. However, there is a killer problem here that caused me endless difficulties. I first experienced it around 1995. I was working on an Arthurian story world, and I built the love triangle into it, Arthur, Guinevere, and Lancelot. And in running through a rehearsal, Lancelot finally succeeded in betting Guinevere. And so he's all excited. And now, of course, this is going to be very high on his headline list because he cares a lot about Guinevere and himself. And boy, this is really important. And so he comes out, and the next person he runs into is Arthur. Now he goes through the calculations. Boy, the fact that I betted Guinevere is really important to me. And I really like Arthur, so I'm going to tell him, hey, Arthur, guess what? I just had sex with Guinevere. Oops. The problem with that is the lack of anticipation. Lancelot needs a way to know that Arthur will be very unhappy if Lancelot tells him about that event. And that in turn requires him to anticipate it. The wrong way to do this is to, treat it like a chess problem where you look at, the tree of possible moves coming out from it. Forget it. That just blows up. That's way too much calculation. Fortunately, with the Storytron system, I developed a very good way of dealing with that. And that is there's an emotional reaction to every event. So, and for every event, when a character learns about the event, he has two reactions: an emotional reaction and a physical reaction, what he's actually going to do about it, how he feels about it, what he's going to do. You ignore what he does, and for purposes of anticipation, you just look at the emotional reaction. And you say, whoa, he's going to be really angry with me if he finds out about this, so I'm not going to tell him. I'm running out of time, so I'm going to very briefly talk about the top end, the most complicated expression of gossip, and that is when we get into secrets and lies. That is the transfer of information that is that is wrong somehow. It's either false information or it's true information that shouldn't, or false information that is communicated, or true information that should not have been communicated. In both of these, the central problem is keeping track of who told whom. You need a linked list going back. Well, I heard this from Joe, and this allows the victim of the lie or the revealed secret to demand, hey, who told you that? And then you can, once you get that, you go back another step. So who told you this? And you can go back to the original person, conceivably. But if you're allowing lies, then at one point, this person is the actual liar, will either lie about who told him it or lie about the fact that he told. And that creates this really clever dilemma where the outraged person doesn't know whether this guy in the chain is the liar or this guy in the chain is the liar, or when he goes to the upper person, when he denies it, there are three people that could be liars here. And so it gets very complicated. Many years ago, around 86 or 87, I think, I wrote up a game proposal for a game I called Lies. and it was about a spy agency, and there's a mole in it, and you're trying to figure out who the mole is, and people are telling lies about what's going on, and you had to figure it all out. I will warn you, lies stuff is easier to deal with than keeping secrets is. Keeping secrets suffers from the additional complexity that a character may not know that it's supposed to be a secret. And so he can plead, oh, I'm sorry, I told your wife. I didn't know it was a secret. I thought she already knew. And that makes matters more complicated. So what I'll tell you is that gossip systems involving lies or secrets are immensely complex. I actually did a little bit of that with, well, in fact, the Storytron technology does have a way of keeping track of lies. It does not have a way of keeping track of secrets. Lastly, I need to talk about uncertainty. This was something I had that played a big role in C-Boot. In many cases where you are communicating a quantity, there is an intrinsic uncertainty. In other words, if you say, well, Mary hates John, are you really sure? That is, if somebody tells you that Mary hates John, could it have changed? Could her feelings have changed since the first person heard that? Or what if somebody is partially lying? That is, they're exaggerating. I did have that in C-Boot. And so you needed to include an uncertainty element in a statement of affinity. And so you said, Mary hates John 5, but I'm only 3 sure of that. And there were icons that indicated this stuff. My experience is that uncertainty is dramatically powerful because it allows a liar to sort of fudge the thing. Mary really hates John, but I'm going to tell her that Mary only mildly hates John. That'll change her attitudes towards Mary. But again, this gets really complicated. But this is the stuff and substance of good interactive storytelling. So we need to research these things, experiment with them, see where they go. Oh, there was one other thing, which I cannot remember now. So we've got 4 minutes left for questions. I've dumped a lot of stuff on you. Do you thoroughly understand every single thing I said? Apparently so. Gosh, I'm a really good explainer.
Hi, Chris. I do have a question. It's not that important, but I was just wondering, earlier you said that a character will check the history book to see if the character that they're talking to, if they know or not the event that they want to talk about. Is that really necessary? Is it not okay just to be like, for one character to say, oh, this event happened, and the other one says, oh yeah, I know, isn't that crazy? And maybe they can just both talk about it, even though they both already knew about it.
That's a good point. The problem though that I experienced was characters reporting to the player events the player already knew, and it got rather tedious. Yes, if you if you build that into your system as a way of triggering a conversation, that you need to have a new verb from the recipient of the gossip that sort of expands on it, that says, gee, yeah, that's true. That Mary, she sure is a bad person, isn't she? So yeah, you can build that in if you want. There's so many possibilities here. I've learned a great deal about clumsy problems. And if you use that, it can be used. And in fact, it can be a feature, not a bug. But you have to build it as a feature.
Thank you.
I have a question.
Sure.
It seems like in the ratio of accessible states to conceptual states, it seems like one of the main ways of solving that problem in games is to direct the player in a particular direction based on the goals the player is trying to achieve. So if the player can imagine that they could get to a particular spot, but there's no motivation for them to try and get there, then they won't be upset that they can't actually get there.
The problem here is knowing the player's motivation. This is particularly troublesome in games where we have all sorts of people who love to try weirdo things. What happens if I try to have sex with this female character? There are always these, there's a word for them, in fact, people who try to do crazy bad things in a game. They're just trying to break it. That's, now maybe you should take the attitude, okay, fine, you want to break my game? It's broken. Now you're stuck. No, it didn't glitch yours.
I don't remember the term.
Anyway, I think relying on a guess as to what the player might do is, you're definitely on thin ice there. Much better to just make it very clear that, oops, Chris Connolly. Hi, Chris. You unfortunately missed the time by an hour. Oops. Daylight savings time, remember? Oh, well. I'm recording it. In fact, I started recording it from the beginning. And it was almost all me talking. So there wasn't much opportunity for interaction anyway. Sorry about that. Anyway, I really have to go. I can't go overtime this time. I've got something else scheduled here. So I'll post this thing as soon as I can. And there's a lot of support material for the various things I've discussed on my website and on the Storytron.com website. And after looking for it, if you still have questions, just send me an email and I'll be happy to answer it.
Thanks for having us.
Okay. And I will see you next month. And if you have a topic to suggest, by all means, send it to me. Who suggested this one? Was it Cornell? Was it you? Oh, well, I don't know. Okay. See you next month. Bye-bye.
Bye.
Bye.